All efforts have been made to ensure the information presented is accurate at the time of recording. Any references made to implied functions remains at the discretion of Broadcom and can change at any time. Welcome, my name is Andrew Firth from the VCF Technical Marketing team. Here, I'm going to show you through the new features and functionality that's been added into VMware Cloud Foundation 9. Let's talk about delivering self-service IaaS with VCF automation. If we want to talk about what's new in VCF automation in one slide, well, this is it. Enhancements to VCF 9 can be categorized across three key pillars, which we'll explore in the coming slides. There's tenant management, cloud governance, and delivering a simpler and improved end-user experience. In VCF 9, supervisor services are exposed across your environments, and users have a choice to consume these services via the UI, the CLI, or Kubernetes native APIs. Users have multiple ways to access and consume services, just like they would in the public cloud. Each service is a namespace scoped, meaning that it operates with defined resource boundaries. In VCF 9, supervisor services are exposed across your environments, and users have a choice to consume these services from the UI, CLI, or Kubernetes native APIs. Users have multiple ways to access and consume services, just like they would in the public cloud. Each service is namespace scoped, meaning it operates within defined resource boundaries. The model provides a self-service experience. Dev teams can move fast and they can consume infrastructure without complexities and all the wait times associated with logging tickets. Which leads us to the topic of tenancy. A modern private cloud is so much more than just a platform. A true end-to-end modern cloud supports secure multi-tenancy. It's an architecture where multiple isolated tenants, which can be teams, departments, or even customers, can come in and share the same platform and infrastructure. Each tenant operates in a logically isolated environment with separate resources, data, configurations, and access controls. Tenancy is now a key construct of VCF 9 architecture, and it's one of the big initiatives that we've introduced with the platform. Tenancy spans across vCenter, NSX, and VCF automation. VCF 9 enables secure multi-tenancy by allowing isolated teams to share infrastructure. This is all achieved through the constructs of vSphere zones, supervisors, regions, projects, and VPCs. With this, developers, for example, can gain self-service access to VMs and containers, while IT controls security, policy, and resource governance. So let's just take a couple of steps back and look at how tenancy is enabled within Cloud Foundation. We start by configuring a vSphere zone. vSphere zones align with vSphere clusters and define CPU and memory resources for workload placement. Zones are isolated for fault containment, and the supervisor will work with them to schedule VMs and Kubernetes workloads across fault domains. The vSphere supervisor embeds a Kubernetes control plane within vSphere, enabling clusters to run both virtual machines and containers. The demarcation here is that the developers use Kubernetes tools, while IT manages resources in vSphere, which eliminates the need for a separate container platform. So now we're at the VCF automation level, and what we do here is that we start to configure our regions. Regions are logical groupings of compute, storage, and networking resources. They're typically assigned within a geographic location. Each region can include one or more supervisors and enables tenant resource allocation, which can be based on performance, capacity, or other features, which the service admin, or in our case the VCF platform admin, can enable. Tenant organizations define isolated boundaries for users, policies, services, and resources. They centralize access control, governance, and billing. Providers assign regional quotas that define each organization's vSphere zone, access, and capacity. And it's at this point where we add the tenant admin persona. Tenant admins create projects. These projects can be logical groupings of related VPCs, users, and policies under one administrative boundary. Each project has its own IP space, its own access controls, and its own security policies, ensuring that it's isolated. A virtual private cloud is a tenant-managed isolated virtual network within a data center. It includes subnets, routers, firewalls, and network address translation, allowing tenants to configure and consume networking resources independently. VPCs support isolation for multi-tenancy, development, and testing, and also application segmentation. Inside each VPC, vSphere namespaces allocate resources from a supervisor cluster to run Kubernetes workloads. These namespaces integrate Kubernetes features with vSphere policies like resource limits, access controls, storage, and networking. Which brings us to our third persona, the tenant. Tenants, like developers and app teams, consume these resources. They can be consumed via self-service, which can be configured using VCF automation. Meanwhile, the tenant and provider admins enforce security and governance. Tenants can deploy VMs and modern apps without needing to manage infrastructure, which improves speed to market and allows IT teams to maintain control and costs, which to those who have experience in managing capacity in the public cloud is a significant advantage. With the quick setup feature, we've streamlined this whole process for you, enabling IT admins to establish organizations more efficiently. The end result is that this is all structured, scalable, and secure. It's a secure multi-tenant monitored private cloud. The quick setup wizard from within VCF Automation helps our customers to streamline the delivery of isolated tenant level resources and streamline adoption. So instead of having to think about all of this yourselves, we make it really simple and quick to deploy. The guided workflow configures everything for you: the regions, creating the organizations, the IP spaces, the provider gateways, and all of the external connectivity, all the way through to the project and namespace creation. With a comprehensive suite of out-of-the-box services, VCF Automation simplifies the deployment and management of IT resources. This allows organizations to quickly scale their infrastructure needs and reduce operational complexities, allowing IT teams to focus more on innovation and development rather than maintaining disparate systems. Out-of-the-box supervisor services are exposed across VCF environments and aggregated into common endpoints that can be accessed through a choice of interfaces, that being the UI, the CLI, or the declarative Kubernetes IaaS API for self-service consumption. Users can leverage a variety of supervisor services, some examples being the VM service that allows you to declaratively define and provision VMs, the VKS service for deploying Kubernetes clusters, the networking service to deploy load balancers, the volume service to deploy persistent volumes, and the supervisor services that help extend the capabilities of the IaaS platform, such as Harbor for the OCI image registry or Cert Manager for certificate management. This list can go on. Self-service IaaS for VCF Automation follows an end-user-oriented approach. End users and app teams can freely consume the out-of-the-box supervisor services, allowing them to deploy and manage VMs alongside Kubernetes clusters and other vSphere-based resources, providing a very similar experience to that of the public cloud. Each configured organization, or what we call an org within VCF Automation, can have specific infrastructure quotas for their region. Orgs enjoy complete network and computing isolation, which means that they are entirely separate from one another. With governance for users and resources, IT admins can enable effective resource management through capabilities like reservations and limits. This helps to ensure that provisioning critical applications, for example, receive the necessary resources without over-provisioning, while also ensuring that new services are delivered at low cost. This setup makes org admins feel like they had their own private cloud, even though the enterprise IT admin manages the shared VCF vCenter resources in the background. The org admin can log into their own portal to create projects and assign it to different lines of business. In each project, org admins can create IaaS namespaces, which define application boundaries. They define limits on infrastructure use, and they can also configure reservations so end users and application teams can easily access modern IaaS services. Each vSphere namespace can be under an isolated networking domain, a VPC. With VCF Automation and VCF9, your customers can implement a YAML-based approach to policy as code to enforce best practices for your resources and apply security configurations. Let's use this example and scroll down to view the policy as code. And click Load Policy Template. The predefined out-of-the-box templates are designed to streamline the implementation of policies as code for both initial setup, that's day 0, and ongoing management, day 2, of Kubernetes and VM environments. These templates serve as a solid foundation, allowing users to easily customize and fine-tune their policies through a user-friendly interface or directly via the Kubernetes command line interface, ensuring a tailored approach to meet specific organizational needs. With label enforcement selected, we click Load. And in this example, here we're enforcing the label prod is applied to all virtual machine resources. With VCF Automation and VCF Operations, end users and developers can easily review a rich set of metrics for VMs and Kubernetes clusters. These metrics for VMs include utilization of CPU, memory, disk IOPS, and network throughput. For Kubernetes clusters, users can review the Kubernetes version and utilization metrics for CPU and memory consumption. One benefit of allowing enterprise IT admins to have more control in production environments is enhanced security. With increased control, admins can implement stricter access controls. They can monitor system activities more closely and enforce compliance with organizational policies. These capabilities reduce the risk of unauthorized access or data breaches, ideal for production environments. Providing application teams more flexibility to consume self-service IaaS resources accelerates development and testing cycles. By allowing teams to quickly provision and configure the necessary infrastructure on demand, they can focus more on writing and testing code rather than waiting for resources. This leads to faster time to market for new features and enhancements. The catalog experience allows users to provision traditional, modern, and generative AI applications. Each catalog item is supported by blueprints, developed and published for the project teams. Using the design canvas, advanced users can create on-demand resources like VMs, Kubernetes, volumes, networks, and storage from scratch, and publish them to the catalog. Centralized content management enables IT admins to easily discover, create, and allocate content libraries directly within VCF Automation, reducing complexity, minimizing errors, and streamlining the overall management process. This leads to increased efficiency and better resource allocation for customers. Before the introduction of VCF9, managing the content library across multiple vCenters and data centers involved a publish and subscribe model. In this model, vCenter acted as the publisher, hosting the content libraries, while the other vCenters served as subscribers. This setup, known as pub and sub, could become quite complicated, especially with many vCenters across multiple data centers, leading to significant challenges in synchronizing content libraries. With VCF9, we consolidate content library management with VCF Automation by connecting to all the vCenters to discover all content libraries. This process allows the IT admin to allocate a content library to one or more organizations. VCF Automation automatically synchronizes these libraries with the vCenters in the background. In VCF9, you can also create a new content library directly within VCF automation. You can also add one or more VM images, and you can also allocate the library to one or more organizations as needed. Org admins can publish content to the self-service catalog with a single easy click. This streamlined process allows them to make resources readily available to end users and app teams, empowering them to access and utilize the content efficiently. The Content Hub management was explicitly designed for org admins and the line of business teams to efficiently manage a wide range of resources. This includes content libraries, virtual machine images, blueprints, and orchestrated workflows. Users can seamlessly organize and maintain these resources in one location, which simplifies the process of sharing them across multiple projects. VCF Automation 9 empowers application teams by allowing them to select multiple vSphere zones to deploy their applications. This flexibility enables teams to optimize resource utilization, enhance application performance, and ensure redundancy across different zones, improving the reliability and scalability of their deployments. By ensuring organizational isolation at the networking level and aligning with NSX tenancy constructs, we provide comprehensive network isolation throughout the stack while guaranteeing immediate internal and external connectivity upon the creation of the organization. IT administrators can also provide organizations with a comprehensive private cloud experience supported by an extensive managed services ecosystem from VMware and partner services. Enhanced visibility and control are achieved by providing deeper insights into the consumption of cloud infrastructure through chargeback and showback methods. This approach allows for more informed decision making and proactive resource management. Furthermore, implementing policy-based controls can reduce costs by optimizing resource utilization and minimizing operational expenses. These controls effectively manage consumption, they prevent over-provisioning, and help eliminate unnecessary costs. A supervisor can be deployed on 3 vSphere zones to provide clusters with high availability and fault tolerance, which is essential for building highly reliable applications. First, ensure that each organization is isolated from the others regarding networking and computing resources. And next, establish network isolation for different application teams within each organization using VPCs. Finally, implement a transit gateway to facilitate communication between VPCs and to enable connectivity with external networks outside the organization.